Acceleration is rate of change of velocity. Okay. So does every moving body has acceleration?
Yes, sir.
Definitely. Acceleration must be there.
No, sir.
A body cannot move with acceleration, without acceleration. Can a body not move without acceleration?
No, sir. It cannot move.
It cannot move. How about bodies moving with constant velocity?
But to get it started, also we have to. We want acceleration, sir.
Okay, the body starts from zero initial velocity and it reaches 5 meter per second and it maintains that 5 meter per second velocity. During this journey, it is moving without acceleration, right?
Yes, sir.
So a body, any body, can move in two different ways. One, with constant velocity, other with changing velocity. And this changing velocity is what you call acceleration. So a body can move in any one of these two ways, either with constant velocity or with changing velocity. And to understand this difference only, we have discussed uniform motion and non-uniform motion in detail. I think we spent a full class on that, uniform and non-uniform motions.
Yes, sir.
The point behind that was to understand this point. So whenever a body is moving, you should understand what kind of motion it has. Is it in uniform motion or is it in non-uniform motion? Uniform motion means its velocity or speed will be constant. Non-uniform motion means its velocity or speed will be changing with time. Or in other words, non-uniform motion is accelerated motion. This is the point. Non-uniform motion is accelerated motion.
Sir, any type of motion needs acceleration, sir.
Hmm. During the start of the motion, you might need acceleration, but once the motion starts, it can be of two types: constant velocity or acceleration.
Sir, if the body is at constant velocity but it is in different direction.
Then also it has acceleration.
Okay, sir.
Sir, when the speed is zero and the object is not moving, it does not have acceleration, but it is in uniform motion, sir.
Yes. In non-uniform motion, the body has acceleration. If velocity is constant, then how much is acceleration?
So 0.
Acceleration is zero. Velocity is constant, acceleration is zero. If acceleration is constant, then what about velocity? If a body has constant
Sir, the
acceleration,
velocity will constantly increase, sir.
the velocity will change. The velocity will change at a constant rate, and this might increase or decrease. In both cases, you say the body has acceleration. In if velocity decreases, you give a special name to it, which is retardation. If velocity increases, if acceleration is constant, if acceleration is constant, two things can happen. One, fundamentally, is only one thing. If acceleration is constant, velocity will change. And this change can be of two types: increase in velocity or decrease in velocity. If velocity is increasing, we say that that acceleration is positive. If velocity is decreasing, that acceleration is negative. Pushing the accelerator increases speed of the car, so your acceleration is positive. Pushing the brake pedal reduces the speed of the car, so your acceleration is negative. Your car is getting retarded. Velocity, acceleration. Velocity, acceleration. Difference must be very, very, very clear. They are not the same. Velocity is different, acceleration is different. If a body has, now from this moment onwards, whenever you hear or whenever you read that a body is moving, immediately you should think or you should try to identify how is that body moving. Is it in uniform motion or non-uniform motion? If you could do this, 50% of your problems will be solved. Immediately, the moment you read is some in any question that a body is moving, you should first of all search and identify how is that body moving, whether with constant velocity or is there acceleration. If there is, if it is moving constant velocity, simple, that will be the easiest question that you can get from this chapter, because you have got only one formula to handle that kind of motion: speed equal to distance by time or velocity equal to displacement by time, if velocity is constant. If velocity is not constant, changing, that means the body has acceleration. Then what to do? That's what we are going to learn today. If a body is in non-uniform motion, moving with acceleration, constant acceleration, then how to study its motion? How much distance does it cover? What will be its velocity? How much time does it take? What will be its acceleration? How to study or how to calculate all these things? That's what we are going to study today. And this is what we call as
Kinematic
kinematic equations of uniformly accelerated motion. Kinematic equations of uniformly accelerated motion. Okay, step by step, word by word. I hope everyone knows what motion is. If position of a body changes with time, then we say that it is in motion. Okay. A body can move in two ways: uniform motion or non-uniform motion. What kind of motion are we discussing here? Accelerated motion. This motion is accelerated motion. That means non-uniform motion. Accelerated velocity changes with time. It might increase or it might decrease. Okay, and how, moreover, how is this acceleration? Uniform. This acceleration is uniform. Uniform means same or constant. Constant acceleration. Acceleration can again be two types: constant, variable. Okay, suppose if I show you like this, a body starts at time t equal to 0 second. Let us say with initial velocity 0. Okay, in 1 second its velocity becomes 2 meter per second. 2 second, 3 second, 4 second, 5 second. Then in the next second it becomes 4 meter per second. In the next second it becomes 8 meter per second. In the next second it becomes 3 meter per second. In the next second it becomes 12 meter per second. Is the velocity remaining constant? No. That means this is accelerated motion. Okay. Is that acceleration uniform? No, because uniform acceleration would have been like this. The body starts from rest. After 1 second, it's Velocity is 2 meter per second, another second 4 meter per second, 6, 8, 10. Here, the rate of change or rate of increase of velocity is 2 meter per second every second. 2 is becoming 4, 4 is becoming 6, 6 is 8, 8 is 10, 10, 12, like that. Increasing, velocity is increasing at a rate of 2 meter per second, which is uniform, which is constant. Rate of increase is constant. But here, it is 2 meter per second here, 4 meter per second. How much is increased? 2.
2, sir.
Okay. 4 here, 8 here. How much is increased? 4.
4, sir.
8 here, 3 here. It is
5,
decreased.
sir.
5.
Minus
3
5.
here, 12 here. It is 9.
9, sir.
So the rate of change of velocity is not same. It is not uniform. So this acceleration is non-uniform acceleration or variable acceleration. Variable acceleration. And how to handle those situations? You will come to that in class 11, not now. Because to handle that kind of motion, we need some mathematical, advanced mathematical methods like differentiation and integration, which you will learn in higher classes. Okay, so we are not going to study this kind of motion here. Which kind of motion? The motion in which acceleration is not constant. We will not study that here. We will study that in class 11. We are going to study only this kind of accelerated motion. What kind of accelerated motion? Uniformly accelerated motion. Uniformly accelerated motion means acceleration remains constant. If acceleration remains constant, many students misunderstand it like velocity is also constant. Is that so?
No, sir.
No.
If velocity increases only, acceleration will be constant.
So the moment you hear acceleration, velocity will change. It's not possible for a body to have acceleration and have constant velocity. It's not possible. Okay. So this is what you mean by uniformly accelerated motion. Uniformly accelerated motion in which acceleration remains constant. Acceleration does not change with time, but velocity will change with time in
Sir,
uniformly accelerated motion. Yes.
sir, in this class only uniform acceleration, sir.
Yes.
Okay.
So uniformly accelerated motion, uniformly accelerated motion, and kinematic equations of such motion. Kinematic means something which is moving, motion which is not at rest. You call that as kinematic. So we have a set of equations which we use to study this uniformly accelerated motion. Okay, what are these equations? Very, very, very important equations. First equation is V is equal to U plus AT. Second equation is V square equal to U square plus 2AS. Third one is S is equal to UT half a T square. Fourth equation is Sn equal to U plus A by 2 into 2n minus 1. And fifth equation is
So S equals
S is
plus
equal to U plus V by 2 into T. These are the 5 equations, kinematic equations. We call them as kinematic equations of uniformly accelerated motion. What does each symbol or each term represent here? We already used these terms here. U is used to represent initial velocity. Initial velocity is velocity of the body at the time of start of motion. V is final velocity. It is the velocity of the body at the time of ending of motion. During the end of motion, velocity that a body has is final velocity V. and A is acceleration. S is displacement. S is not distance, it is displacement. T is time. And in fourth equation, you have this N. N. So this N represents nth second. Nth second. These are the terms that we are using. U, V, A, S, T, N. Okay. Now, see, if you take the first equation, it says that V is equal to U plus AT. Final velocity is initial velocity plus acceleration into time. So this equation, and if you observe, every equation has 4 parameters in it. First equation, U, V, A, T, 4 quantities. Second equation, U, V, A, S, 4 quantities. Third equation, U, S, T, A, 4 quantities. Fourth equation, S, U, A, N, 4 quantities. Fifth equation, S, U, V, T, 4 quantities. So each kinematic equation has 4 quantities in it. And equation number 1 relates velocities with acceleration and time. Equation 1 relates velocities, initial final velocities, with acceleration and time. And equation 2, the same initial velocity, the same final velocity, the same acceleration, but here it is displacement. Here it is time. Third equation relates displacement and initial velocity with acceleration and time. Fourth equation, this is one a slightly different kind of equation which you should understand. See, the difference between third equation and fourth equation. Difference between third equation gives you displacement. Fourth equation also gives you displacement. Then what is the difference between these two equations? The difference is third equation gives you displacement of a body in a interval of time t. In a interval of time t, where interval of time is duration of time. That can be 1 second, 2 seconds, 3 seconds, 10 seconds, 1 minute, 10 minutes, 1 hour, 10 hours, 100 hours. All these are durations of time or intervals of time. So if you want to find displacement of a body during a interval of time or during a duration of time, then you use S equal to ut plus half at square. Suppose ఎవరో మ్యూట్ చేసుకోవాలి. తౌఫిక్, మ్యూట్ యువర్ ఆడియో. తౌఫిక్, any question? Any question? Taufik. Right. So equation 3 gives you displacement of the body in a interval of time. What does it mean? Let us say a body starts at time t equal to 0 with some initial velocity and it is moving with some constant acceleration a. Okay. Then 1 second, 2 second, 3 second, 4 second. At the end of 4 second, it will be covering some displacement or distance. Okay. How much is that distance or displacement? Not distance, displacement. How much is that displacement that the body covers in 4 seconds? That is given by S equal to ut plus half at square. Or you want displacement in 2 seconds, 3 seconds, 10 seconds, like that. On the other hand, fourth equation, Sn equal to u plus a by 2 into 2n minus 1 gives you displacement of the body in a particular second. In a particular second. Particular second means, let us say the same situation. Body starts at time t equal to 0. It travels for 4 seconds. But now I want the distance traveled by the body or displacement of the body in second only. Second. What is second? T equal to 0 to 1 is first second of journey. 1 to 2 is second of journey. 2 to 3 is third second of journey. 3 to 4 is fourth second of journey. I want the displacement of the body only during second, which is during this time, this 1 second. Or I want the displacement of the body during fourth second, only during this part, which is this. Okay. Or which is this. Then I have to apply Sn equal to u plus a by 2 into 2n minus. Or if you want the total displacement of the body, right from time t equal to 0 to t equal to 4, this total displacement over the entire duration of time, then you have to use third equation, ut plus half at square. Is this difference clear?
Sir, I have a doubt.
Oh,
Sir, if in a equation, if we have to use the fourth formula,
oh,
n is there, no sir? In the place of n, we have to write the which
oh, which
second we
second?
want the
Which
distance,
second?
sir.
Yes, n is the particular second during which you want the displacement.
Okay,
Suppose
sir.
in question it is said that a body starts from rest and moves with some acceleration 2 meter per second square for 10 seconds. Find its displacement in sixth second.
Then
Then
we have to write as 6, no, sir.
value of n will be 6 there.
Okay, sir.
This is a very basic difference between third equation and fourth equation. So I will write it here. Equation 3 gives displacement in an interval of time which is t, whereas equation 4 gives displacement in a particular second, in a particular second of journey. There is a difference. Okay. Then fifth equation. Fifth equation is S equal to u plus v by 2 into t. U plus v by 2 into t. U plus v by 2 is, you can take it like the average velocity. U is initial velocity, v is final velocity. Initial value plus final value by 2 gives you the average of it. So u plus v by 2 is average velocity. So displacement is equal to average velocity into time. That's what fifth equation says. And these are the 5 equations. And these 5 equations, are applicable only when the body is moving with constant acceleration. If the acceleration is not constant, you cannot apply these equations. You have some other methods. If there is no acceleration, you don't need these equations. If there is no acceleration, you don't need these equations. You have speed equal to distance by time or velocity equal to displacement by time. If there is acceleration and that acceleration is constant, you need these equations. And which equation to use for which problem? That is a very important thing which you must learn, which you must understand. And you will understand that which equation to be applied to solve which kind of question. You will understand that only when you understand what each equation relates. Equation 1, velocity, time. Equation 2, velocity is displacement. Third equation, displacement, time, acceleration. Fourth equation, particular second, displacement in particular second, like this. So if you understand what each equation has in it, then you will understand which equation to be applied to solve what kind of question. You'll learn that with practice. Only thing is, you should solve many number of questions, then you will get accustomed to this. Okay. Now, we have these equations, right? But let us see how we get these equations. Derivation of kinematic equations. If you take the first equation, what is it? V is equal to u plus 8.
Sir,
V is
one
equal to u
point.
plus 8. How do we get this equation, or what is its derivation? Simple. See, we know we have the definition or formula for acceleration. What is it? It is delta V by delta T. That means change in velocity, final velocity minus initial velocity by T. Or I will not write this delta V by delta T. I will directly write change in velocity by time. Change in velocity, final velocity V minus initial velocity by minus initial velocity U divided by the duration of time T. From this, AT is equal to V minus U, or from this V is equal to U plus AT. That's all. So we have got this equation from the basic formula of acceleration. Next, second equation, V square equal to U square plus 2AS. V square equal to U square plus 2AS.
Sir,
Yes.
sir, we can also write this equation as v square minus u square is equal to s.
No, that is a different term. V square minus U square equal to S. Yes, you can write. You can write. No problem.
Sir,
Oh,
sir, here AT is equals to V minus U root, no, sir?
yes.
When they go from LHS to RHS, then they have to become minus, no, sir?
Say, check it once with your mathematical rules and confirm whether they are right or wrong.
V is going from RHS to LHS, then it should become minus, no, sir?
I am not sending V to LHS, I am sending U to LHS. Okay.
Yes.
Next equation, V square equal to U square plus 2AS. How do we get this? For this, Right. See, I will take this basic thing, which is S is equal to displacement is equal to u plus v by 2 average velocity into time. Okay. But already time is from this equation, from first equation, if it is a is v minus u by t, from this t is v minus u by a. Okay. Therefore, take this t and put it here. This is 1, this is 2. Substitute 2 in 1. What do you get? S is equal to u plus v by 2 into v minus u by a. Okay. Or I will write it like v plus u by 2 into v minus u by a. V plus u into v minus u. A plus v into a minus v. A square minus b square. V square minus u square by 2a. Or v square minus u square is equal to 2as. That means v square is equal to u square plus 2as. Second equation. Next one. Third equation. S equal to ut plus half at square. Again, we'll start with the same thing. S is equal to u plus v by 2 into t. U plus v by 2 into t. We have first from first kinematic equation, we know v is equal to u plus at. This is 1, this is 2. Put 2 in 1. What do you get? S is equal to u plus, in place of this v, I'll put this v. So I get u plus at divided by 2 into t. Okay, that means here if I open the brackets, t is there. So I get S is equal to ut 2u. U plus u is 2u. 2u plus at into t by 2, which is 2ut plus at square by 2, which is, if I distribute the denominator, split the denominator, what do I get? Ut, 2 cancel, plus half a t square. So S is equal to ut plus half a t square. Third equation. We are deriving the two equations only from their basic relation. S is equal to u plus v by 2 into t. And the fourth one, which is Sn equal to u plus a by 2 into 2n minus 1. Into 2n minus 1. Okay. See, for this, you should understand first of all, what is this n? What does this nth second mean?
Sir, one can
Let us
scroll up.
say a body let us say, to derive this, let a body travel for n seconds. N seconds. That n can be 1 second, 2 second, 3 second, 10 second, any number of seconds. In that situation, its displacement is how do you write its displacement? S is equal to
Displacement by time.
S is equal to ut plus half at square. I am applying S is equal to ut plus half at square. So time we have taken as n seconds here. So it is un plus half into a into t square. T is n seconds. So n square. Okay. This is the displacement of the body in n seconds. Let us say this is time t equal to 0. From here, the body starts with some initial velocity u and acceleration a. It travels for some n seconds. So here time t is equal to n seconds. Right. Then what is this displacement? It is displacement right from here to here. Okay. Or I will call this as displacement in n seconds. Displacement in n seconds. Okay. Now, the displacement of the same body, the displacement in n minus 1 second is n minus 1 second means, let us say it is traveling for 10 seconds. N is 10. In 10 seconds, its displacement is here to here, this entire thing. Now I am calculating displacement in n minus 1 seconds, 10 minus 1, 9 seconds. So if it covers here to here displacement in 10 seconds, it will cover this some displacement which is here to here in 1 second less. Okay. So this is displacement in n minus 1 second. And what is this time? This times t is equal to n minus 1 second. Okay. This one. How can I write that displacement in n minus 1 seconds? So yes, n minus 1 is equal to, same formula, is equal to ut plus half at square. U into n minus 1 now, because time that we are taking is n minus 1 seconds, plus half a into, in place of t, n minus 1 whole square. This is equation 2. Okay. Then if I want the displacement of this body, which is this, what is this displacement? This displacement is displacement in one particular second, right? Let us say value of n is 10 seconds. The body travels for 10 seconds. Then this will give me displacement in 10 seconds. And this will give me displacement in 10 minus 1, which is 9 seconds. Okay. If I want to displace, if I subtract this from this, what do I get? I'll get displacement in 1 second, which is the nth second. Are you getting this point? By subtracting 2 from 1, I will get displacement in the last second of journey of the body, which is what our required equation is. So I will subtract 2 from 1.
Sir,
Yes.
sir, I didn't understand, sir.
Which part?
The first equation and the second equation, I didn't understand.
These are not new equations. I am using the same equation that we have got, which is S is equal to ut plus half at square. In place of t, I am putting n.
That means t is equals to n, sir.
Yes. We are
Okay.
assuming that a body travels for some n seconds.
Okay, sir. N is a variable.
Nth second is the last second of journey. Nth second is the last second of the journey. I am writing displacement in those n seconds, right from starting to this here. Then I am taking n minus 1 seconds, 1 second less than the total number of seconds. During that n minus 1 seconds, the displacement of the body is this much. If I subtract this from this, I will get this, which is the displacement of the body in the last second of journey.
Sir,
Oh,
there should be 1 minus 2, right, sir, equation.
yes, right. 1 is more, no? 1 is larger, 2 is smaller. So 1 minus 2. Subtract 2 from 1. Subtract 2 from 1. What do you get? Sn minus Sn minus 1 is equal to un plus half an square minus of un, not un, minus of u into n minus 1 plus half a into n minus 1 square. Can you simplify this? If you go, just simplify it step by step slowly, you will get the required result. This is un plus half a n square minus in brackets, in square brackets, is un minus u plus half a into n minus 1 whole square, n square minus 2n plus 1. Again open the brackets there, un plus half a n square minus un minus u plus a n square by 2 or plus half a n square minus 2na by 2 plus a by 2. Okay, so any cancellation, this 2 cancelled. What do you have here? Un plus half a n square minus un plus u minus half a n square plus na minus a by 2. cancellations, un, half an square, half an square. So you have u plus na minus a by 2. I can take a common, u plus a into n minus 1 by 2. LCM u plus a into 2n minus 1 by 2, which is u plus a by 2 into 2n minus 1. So ultimately displacement in nth second is this. This is how you get the 4 kinematic equations, their derivation. You will get the PDF of this after the class or before next class. You should go through all these derivations and understand. First of all, you should memorize these equations. Just how you memorize tables, multiplication tables. 2 3s are 6, 2 4s are 8, 2 5s are 10. Similarly, you should memorize v equal to u plus at, v square equal to u square plus 2as, s equal to ut plus half at square, sn equal to u plus a by 2 into 2n minus 1, and s equal to u plus v by 2 into t. You should memorize these 5 equations and you should remember them at least for the coming 4-5 years until you complete your class 12, because
Sir, can you
these
move
are
up?
these are going to be with you for until you complete your class 12.
Sir, can you
Then
scroll up?
you'll get the PDF. Listen to first what I am telling. You'll get the PDF, you can copy from. Then you should understand what equation gives you what quantities or what equation relates which quantities. Then try to understand how we are deriving them. These are the things that you have got to do before our next class. Okay. Right. So do these things. We will continue in the next class.
Thank you, sir. Bye, sir. Good night, sir.